Our fourth speaker this morning is Mr. Jim Little. Jim is a native Oregonian and a native Portlander. He's a graduate of Cleveland High School and Linfield College. He studied meteorology at the University of Texas, the University of Utah, and Mississippi State University. Jim has also held various positions on the Executive Council of the Oregon AMS over the years. He began his meteorological career in 1971 as a second lieutenant in the United States Air Force. Jim's military duty stations included Austin, Texas, Tacoma, Washington, Guam, and Omaha, Nebraska. Jim has been a television meteorologist in Idaho, Utah, California, and here in Portland. Excuse me. Jim currently provides specialized forecasts for the Oregon Department of Forestry, Department of Agriculture, and Department of Environmental Quality, as well as private clients. Ladies and gentlemen, Mr. Jim Little.
I Steve, all those jobs, it sounds like over the years I can't hold a job. Probably the case. All right. Objective techniques and analog seasonal forecast. That's kind of a highfalutin title for which is not all that complex talk. It's great to see all of the people here. I mean, this is amazing. I can remember going to these things when they were in a BPA conference room over at the Flight Center, and we were lucky if we got 15 people show up. So this is great. And the collaboration between OMSI and AMS also is great. I think that's a win-win for both organizations. And whoever came up with that idea was brilliant. I think that's a great idea. All right. You know, most of what people are doing here is some sort of analog forecasting, where you come up with an analog year and use that for your forecast for what's coming up in the future. And about this time of year, there's a lot of chatter online with people throwing years back and forth. 1960, 1976. And, oh no, that was La Nina, El Nino, La Nina, and it was, you know, and that sort of thing. And it's a lot like, you know, it's Muhammad Ali versus Joe Louis, and Hank Aaron versus Babe Ruth. You know, I mean, what I want to do is come up with an objective way of picking those analog, make some rules to pick those analog years, and see how those analog years do, not just in the coming year, but you can go, once you have an objective way of picking analogs, you can go back and look at previous years and see how they did. And then you can start adjusting those rules. So what I've been working on is kind of a framework, a computer program, if you will, to allow me to do this, to come up with an objective method of choosing the analog years, and then eventually be able to verify those on past seasons and see how they do. And then you can start altering the rules. So,
Can everybody hear Jim okay, by the way?
everybody here okay?
You want a little louder? A little louder.
A little closer to the microphone, okay. Let's see, move forward. Okay, analog forecasting. That's what analog forecasting is. I'm going to talk a little more about that. Objectively picking the analogs, how I've done that so far. Some tools for interpretation of those analog forecasts. And then since this is what will the weather be like, this is a work in progress, so don't hold me to this, but I'll show you what it's come up with for this coming season. And then where I want to go with some future developments. So analog seasonal forecasting, it's fairly simple. You look at what has happened this year so far, and then you look at past years that are similar to this year, and then you see what subsequently happened in those past years and use that as the basis for your forecast for what will happen this coming year. The key here is similar. How do you decide what's similar? Well, as it turns out, virtually anything you can talk about when you're talking about climate, somebody has reduced to an index. And there are a number of these indexes, and there are indices, and the indices are numbers, and the numbers are fairly easy to compare. And here's a not complete list of some of the climate indices that are available. Here's the oceanic, this is past data, it's not current data, but this is the oceanic Nino index. Here's an idea of what you do. You find some years that were similar to this year so far, and then you see where did it go. And not just where the indices went, but what happened with sensible weather. Was it hot or was it cold? Was it wet or was it dry? So that's the basis for analog forecasting. What I try to do is automate that process. What I do is compare each previous year to this year, compute a goodness of fit for those curves, which is a fairly simple process. It's not very sophisticated. I sort that goodness of fit. The low numbers, as it turns out, the low numbers are good and the high numbers are bad, so you simply do a sort, save the results, and then do that for multiple indices. And find a consensus for the analog years. All of the programming is done in PHP. All of the number crunching is done on a web server that I think is located in Texas. I don't know. I mean, you can do it all over the web. What I get then is a list of the best fit analog years for various indices, for various periods. I've been doing it for 9 months, 12 months, 18 months, and 24 months. And again, this is old data, so pay no attention to these numbers, but this is what I end up with then, is my consensus best year to get a little report like this. I also get a report like this, that for each month and for each climate division in Oregon, I get this printout. And what I have here, let's see, here's the pointer. What I have here is this is temperature, this is precipitation. Across the top, we have the median, the average, or the mean, and then tercile boundaries. That is to say, 1/3 of the years fell below, 1/3 of the years were above, and 1/3 of the years were in between. Then for the analog years, you just look at that and compare this, both to a 2 category, compare to the median, were they above or below, and to the 3 category, were they above, near, or below. Figure the percentages, and then that's my forecast. Down here is my objective forecast. Now I compare things to the median rather than the average, because you notice that the median is actually less than the average than the mean. And you can actually game the system because of the skewed distribution of rainfall amounts. Most of the time, the rainfall is less than average. Not all the time, but most of the time, so you can win some bar bets that way. So here are the indices that I've used so far, and they're heavily weighted towards ENSO type indices. There are a couple others here, and the choice of these is pretty much arbitrary after the El Nino ones, and that's because I looked for indices that were available easily online, that I could easily parse into a format that I could throw as a subroutine that does the best fit analysis. And I'm becoming kind of a Jedi master of regular expressions doing this. But here are the analog years, and you might recognize some of those. They're the same ones that Pete used. All 5 of Pete years are on this list. And these happen to be just in numerical order. But 2008 was the top year. That was my best fit. So take what you will from that. Comparing those analog years to the SOI from the Climate Prediction Center. And these are not the best fits to the SOI. These are those analog years and how they fit the SOI. And then, okay, but then they kind of go all over. But most of them do stay in La Nina territory, at least through the next 6 months. So that matches that. Okay, taking those analog years and compositing, what do we get? Here's 500 millibar heights. A little bit of a ridge over the western U.S., but also some troughiness over the southwestern U.S., so maybe a little split flow in November. December, the ridge moves back off the coast. Here's January, ridge moves back on the coast. Now, a little bit of troughiness along the coast for February, and again, maybe some split flow for March, and then some troughiness off the coast for April. Looking at the anomalies, positive anomaly at 500 millibars for November. The December anomaly moves back offshore. That's great if you're looking for some dumps of cold air into the Pacific Northwest. January, 500 millibar anomaly, cold. February, cold. Actually, low heights. And then March, the positive anomaly moves back closer to the coast. And remember this, the positive anomaly there. And then for April, a mild, weak negative anomaly. 850 millibar temperature anomalies above for November. December, we're kind of in between. And again, December in between, that's probably good. Occasional dumps of cold air maybe. And then 850 millibar temperature anomaly is negative for January and February. And then March, it's negative. Remember we had a positive 500 millibar anomaly and now a negative 850 millibar temperature anomaly. So warm above, cold below, stability. Maybe March is going to be a quiet month. Although I've got something else here that says maybe it's not going to be, so stay tuned. Here's April. It was negative as well. Looking at the climate division, I'm flying through these so we can catch up some time. There's not a whole lot here that you can get on the precip ones. Let me go back to November. A warm November across the country. Not a whole lot of information in any of these for precipitation. But one thing I do know is there's no indication from these analog years of rain in Texas, so I would think the Texas drought is probably going to continue. Here's December. It turns cool, and then back to warm weather for January for much of the country. The warmth moves down to the south and east, and a lot of rain through the lower southern plains up through the Ohio Valley. Here's the March pattern, and here's the April pattern with some cool across the north and in the southeast, and again, kind of a mishmash precipitation-wise. Another thing that I've done that looked at temperatures just for Portland for those analog years. What I've got here, this is the high temperature curve, and this is the low temperature curve, and the blue is for the period of record. And these are not the smooth averages that you see from the National Weather Service. These are actually, took each day, added up and divided by the number of days. And so the blue line is the period of record, the red line is the average for my analog years. So what do we get? Well, this is for November, and a spike up in the nighttime low temperatures there, first part of the month. What would cause a spike up in the nighttime low temperatures? South winds, maybe. So, maybe there's going to be a windstorm sometime during the early part of November. However, the 60 GFS this morning did not support that, so I did this about 3 weeks ago. Here's December. Oh, let me go back to the other thing is generally warm temperatures toward the end of the month, slightly above average temperatures, so maybe a mild Thanksgiving. December, kind of warm toward the first part of the month, spike down there, about the 13th or 14th. Not real cold, but a spike down, so maybe we flirt with some cold air then, and then some cold weather, especially nighttime lows, coming up toward the end of the month. Here's January. What strikes me there is a mild early few days in January, especially, let's say, the 2nd through the 8th, something like that. And then a spike down toward the end of the month, so that's our next chance for, if you buy this, for some cold weather toward the end of the month of January. For February, this is interesting. Almost all of the temperatures are below average until you get toward the end of the month, with an interesting spike down there about February 14th. One of the things I did was I then looked at the surface pressure pattern for February 14th over those 6 years. This is a composite of those 6 years, and I thought it was pretty interesting. I drew in the H's and L's and the fronts, but that looks like an Arctic outbreak to me. And here's the temperatures for that same day. The 6 years composited together. These are in Kelvin, so the freezing line is close. We'll see. Back to March, spike up there, the 17th, 18th, along in there. Another chance for a windstorm, maybe. And then big variation, ups and downs through April, which would indicate passing storms probably. So a lot of active weather, but averaging out not too far from long-term averages. So here are the analog forecasts, objective analog forecasts from this system by month for Climate Division 2, the Willamette Valley, and then some comments of mine that are very subjective along the bottom. So windstorm, maybe mild Thanksgiving. For December, flirt with cold air, 12th and 14th, and then possibly some Arctic events toward the end of the month. For January, warm spell there, the 2nd through the 8th, and then maybe more Arctic air toward the end of the month. February, of course, the Valentine's Day snow. You heard it here first, it happens. If it doesn't, I'm out of it. March, maybe a wind event toward the middle of the month, and near average temperatures, below normal precipitation. For April, it averages out slightly below, it came out in the below category for temperature and near average for precipitation, but an active month. All right, one other thing, how about mountain snow, and especially in terms of ski areas opening. And I don't have data for all the ski areas, but I do have data for government camp, and here's a look at those 6 analog years and what they were doing through the month of November. And 4 of them were good. 4 of them probably, we did have a Thanksgiving opening, and 2 of them were probably not good for a Thanksgiving opening. But 4 out of 6, 66%, that's probably not a whole lot different than the average, long-term average for Thanksgiving openings for ski areas. So probably not a whole lot of information here. Also looked at Christmas. Christmas vacation is a big thing for the ski areas. And 4 of those years were pretty good. 2 two of them would not. I'm not sure what this says if you were a ski operator, but perhaps it means invest now in snowmaking equipment. Maybe, I'm not sure if grooming practices can conserve snow. Maybe they do that all the time anyway, I don't know. But anyway, just some ideas about what might happen for the winter in the mountains. Further development, more indices. Again, it's just a matter of finding them on the web, parsing them into a format that the rest of the computer program can use. Write routines to produce and verify historical forecasts. That's a big job, and I haven't done this yet. It's a spare time effort, and I work on it when I can. Once I do that, then I can start playing with indices and the weighting of indices and the weighting of time periods and figure out which ones might contribute more to a more accurate forecast. So that's it. There's a summary of the Willamette Valley forecast again, and I guess we'll hold questions until later.
After lunch.
Okay, thanks.
Thanks, Jim.